And hello, everyone. Thank you for joining us today. I am Julie Stottlemyre, and I'll be your moderator. It's my pleasure today to welcome you to our webinar on Guardrail. Our goal with these webinars are to ensure our employees receive the technical training necessary to increase their knowledge and to successfully deliver projects. I'll go over just a few items before we get started with our webinar. We are scheduled for 2 hours today, and we anticipate some questions, and so we have left time in our presentation for some questions and answers as well. We are recording today's webinar, and we will place the recording in Mo.U for future reference. This webinar will also be added to the course catalog of the Program Delivery Training Program. All lines are muted during the presentation. However, we will have the question and answer function open. So I encourage you to send your questions. Select the drop-down box for all panelists when you send that question, and we will be monitoring these questions during the presentations. And if needed, we will go ahead and address any of those questions at that time. Otherwise, we will wait to the end of the presentation, and we will go through those questions and answer those. The presenters will also be able to take verbal questions. You will just need to raise your hand, and we will unmute you and ask you to ask your question in that manner too. We know Guardrail has a lot of scenarios and a lot of different applications, and so we're trying to hit the most common ones. But we know that everybody's probably going to have questions for different scenarios. So if you could kind of hold those till the end, we'll kind of walk through those afterward rather than disrupting each scenario we run through. For today's webinar, we have two presenters. We have Sarah Kleinschmidt and Nick Boltenberg. Sarah is our Engineering Policy and Innovations Engineer in Central Office Design Division. And her role is related to Guardrail specifically. She does many other things, but for Guardrail is to ensure our EPG guidance, policies, standard plans, and standard specifications are up-to-date and accurate. Sarah is an advocate for safety for the traveling public and all those performing work and maintenance on Missouri's roadways and bridges. She also works with Nick, and they provide a valuable and safe solutions for non-standard Guardrail options, so anytime you have questions. Sarah has been with MoDOT for over 20 years in various roles from design, construction, inspection, to pavement and material approvals. Our second speaker is Nick Boltenberg. He is our roadside design specialist in Central Office Design. And Nick's roles and responsibilities include maintaining guardrail and guard cable specifications, the standard plans, the EPG guidance, and to assist the districts with different design options. He is also the co-lead on our MASH implementation team here at MoDOT to determine crashworthiness of the devices that we use on our Missouri roadways. Nick has just over 4 years of experience at MoDOT so far, and with this last year and a half being spent in Central Office Design. Before that, he was in Highway Safety and Traffic Division in Central Office, where he worked with various tasks, but a large majority of that was involved with work zones and crashworthy devices as well. So we are happy to have Nick and Sarah here today. And at this time, we will turn it over to them to get started.
Okay, hopefully everyone can hear me okay, but thank you, Julie, for the introduction. Like Julie said, my name is Nick Boltenberg, and today Sarah and I will be discussing our guardrail design and some design examples with you. We're very aware that guardrail is not always the easiest design, but hopefully you will be able to take away some items that will help you in the future. So with that, I think we're going to go ahead and jump right in. So to begin this course, we just wanted to identify some learning objectives and some outcomes that you will see throughout this class. You may or may not have a knowledge base on some of these discussion topics, but what we really hope to do is to be able to provide you the tools to begin learning and building on what you know already. As you probably all know, Guardrail is very important, but installing it correctly is even more important. And so those are some of the things that we're going to help you identify. So some learning objectives for this class are going to include, we will be reviewing some of the initial EPG policy and guidance related to the length of need and documentation. We're going to be discussing some of the clear zones and the clear zone concept. We're going to be able to help you identify the correct guardrail standard plan based on the installation and some of the design scenarios that you may have. We're also going to take a look at the different MASH and NCHRP 350 installation options. As you probably are all aware, MASH is the current direction across the state and largely across the country. But sometimes, the MASH items that we have just don't always fit the design. We're also going to take a look at the qualified products list, which is otherwise known as the QPL, and understand its importance. And then lastly, we will review the standard installation analysis and some design examples on some either unique or common design situations that you may see here at MoDOT. So the very first item that we're just going to cover is just some initial EPG policy and guidance related to Guardrail and some of the tolerance limits associated with it. Anytime that you have a question about Guardrail, EPG 606.1 is a great place to start and review. If you have any questions about some of the language or the intent, never hesitate to reach out because Sarah and I are always available and we will be able to help you clarify any questions that you may have regarding some of the information in there. With that, one of the first things that we would just like to identify is a standard run of MGS Guardrail. Anytime new Guardrail installation occurs, this is really what it should look like, and these are some things that you're going to want to be able to identify in the field. The very first thing with MGS Guardrail is that it actually has a standard height of 31 inches from the road surface to the top of the rail. This is slightly taller than the previous standard, but something we should be mindful of because it is actually taller for a reason. Vehicles are getting larger, and so we want to be able to make sure that we're capturing these larger vehicles. The blockouts are larger as well. MGS actually uses a standard 12-inch blockout versus an 8-inch block on the old standard, so that is something to be mindful of. We need to always make sure that we're using the 12-inch blocks because that is our standard. And then lastly, the post spacing is 6 foot 3 inches, which is actually not changed from the previous standard, but one major component that has or that is related to this and that's actually the splice location. If you look at the splice, it is actually located between the posts instead of on the posts, and this is easily one of the largest indications of whether or not the rail is new. So if you look at this picture here, and I know it's kind of grainy, but you'll be able to see that the splice is at the mid-span between the posts. So anytime that you're driving, and you see some guardrail and you're wondering whether that's the newest standard or not, that splice is, like I said, the easiest indication of whether it's been upgraded or not. Now, one of the biggest questions asked is that if MGS has any tolerance limits. Yes, MGS does have one. The tolerance limits for MGS is 3 inches, or essentially a height of 28 inches. And this is just really to account for 2 future overlays. So now keep that in mind, though. If you do decide to do a thicker overlay, the MGS actually may need updated sooner to ensure that we are still meeting our standards. So anytime a height is mentioned, we are referring to after project completion, which is very important. EPG 606.1 highlights several placement and replacement guidelines, but I want to just identify a couple here that may go unnoticed or maybe are not as known. So the very first one is going to be that existing rail below 27 3/4 inch height or above 24 3/4 inch height can actually be left in place. But there are 2 conditions that go along with this. Number 1, it has to be serviceable, and number 2, it actually has to be on a minor route. So this is kind of a situation where Guardrail has been untouched for several overlays or just years in general. So maybe it was installed to a previous standard, but it just isn't meeting our current standards. So in these situations, you're always going to want to consider replacing it to the standard 31 inches. The reason for that is because we don't want to come across a kick the can scenario, for lack of a better terms, because it actually may be a while before that roadway is touched again. And this is just a good opportunity if we're in the area to go ahead and upgrade it to our standards. The second thing to be mindful of is that if 50% or more of the runner rail is damaged, it must be replaced with MGS. The reason I bring this up is because of these kick the can scenarios. and the guardrail being left untouched on these projects. The replacement of all of it still needs to be discussed and established, which is essentially having a backup plan. We don't want to have that rail get hit and then have a situation where we need to make some modifications to be able to meet our standards. So always be thinking of that and having that on the forefront of your mind. So like I said, if you decide not to upgrade the rail, just think about it. Be mindful of how you would like to get it to our standard 31-inch height. So the next thing that we're going to discuss is the length of need calculation and how that ties in with the clear zones. As you're all probably familiar with, this table on the right actually is from the Road Sign Design Guide. And anytime MoDOT actually conducts a length of need calculation, this table is referenced and is actually found in our length of need calculator. So the length of need calculator actually considers the clear zone when doing its calculations, and which is very important. Anytime that you are performing that length of need, you do need to identify that clear zone. Now, when it does come to shielding objects, that is actually the fifth term, or the fifth option in terms of the clear zone concept. So, while determining the length of need for an object is important, other options need to actually be considered first. Number one, we always should be looking at removing the obstacle instead of actually having it out there. Ideally, not having anything to protect within the clear zone is the ideal scenario. Number two, we need to look at redesigning the object to be safely traversable so that a vehicle can actually safely pass over it, but that object can still function as needed. An example of this is a 36-inch culvert, as it is actually traversable by a vehicle and may not need any protection at all. Now keep in mind, if you are designing something to be traversable, you still need to look at other objects in the clear zone. So just because something is traversable doesn't mean you won't have guardrail for a specific item. The third thing that we need to look at is relocating the obstacle, which I know is easier said than done, but it is still something that we need to consider or at least try and have those discussions. Or something else we can do is actually design the roadway further away from the obstacle. So if we are in an opportunity that we may be able to shift the road or shift the design a little bit away from that obstacle, that's something that we also need to be considering and looking into. The fourth option that we need to consider is actually just making the object breakaway. There are lots of options for objects to become breakaway, and especially signs. Sometimes you may have a very large sign that you're installing, but there are breakaway options. So maybe do a little research before deciding to shield it, and you may be surprised about what you find. And then the fifth option, finally, it is actually time to consider shielding the object and performing that length of need calculation to safely protect the object within the clear zone. If we cannot achieve steps number 1 through 4, this is when shielding should be considered. So never automatically assume that shielding an object is the correct design if we have the opportunity to do one of these other steps. Now, why is determining the length of need in the clear zone so important? So we all know that guardrail has been crash tested and actually protects a driver from hitting an object. But guardrail is still an object itself, and it's actually not a guarantee. The vehicle is actually designed to interact a certain way, but sometimes it just doesn't, and that can go on for various reasons. But really, ideally, in a perfect world, no new construction should have any object in the clear zone. There would be perfect slopes, no objects to hit, and certainly adequate recovery areas. But we all know that the world we live in is very far from perfect. The last thing I just want to hit on is to make sure that we're always hand checking your calculations and documenting the length of need. Double checking to make sure that we are correctly shielding the object does not hurt, as it is very important that we are providing enough protection. So the next thing that we are going to discuss is the post embedment and its importance. As you have seen in the standard plans, MoDOT has 2 post sizes to use kind of depending on the scenario that you are encountering. Number 1, the very first post that we're going to consider is a 6-foot post, or we also have what we call an 8-foot post. So when it comes to choosing one over the other, the 6-foot post is actually our preferred standard. The reason for this is because the 6-foot post actually provides more favorable slopes behind the guardrail, and it actually provides a 2-foot pad behind the guardrail. Now this 2-foot pad actually accomplishes a couple of things, and you're going to see why it's important. Number 1, it actually allows the post to be flexible enough to catch the vehicle without being too stiff. So it actually redirect the vehicle as intended. And then number 2, it actually provides more of a flatter surface for the vehicle to interact with the guardrail. So when the vehicle interacts with the guardrail, it will not automatically start descending down the slope, and hopefully be redirected a little bit smoother. Now, with that being said, we certainly understand that sometimes 8-foot posts just have to be used, especially in areas where grading is not feasible or that we cannot achieve the 2-foot pad. Maybe the slope is very steep or the cost of graded is just no longer a benefit to the project. So now we're starting to kind of get into that benefit versus cost of the project. The 8-foot post does have its limitations though. So just because a 6-foot post cannot be used does not mean that an 8-foot post is going to be the perfect match either. The max slope for an 8-foot post is ideally a 2-to-1. So if it's steeper, you may need to consider other options. The 8-foot post can actually also only be a maximum of 1 foot down the slope to maintain the correct soil contact, which you can actually see in the picture here. So if you can't get the 2-foot pad and it's actually going to be longer or more than 1 foot down the slope, we really need to start considering other options than the 8-foot post. Really, one of the biggest misconceptions that we see with 8-foot posts is that once it's used in one location along a run of rail, the entire run actually needs it. This is not true, but it's something Sarah and I see frequently. So if you have a portion that needs 8-foot posts, that is perfectly fine. But 6-foot posts can actually be interchanged once an area is feasible for grading. So again, this is getting us back to that 6-foot post because it's our preferred standard. So anytime that you have an area where it's starting to become more flatter, maybe the grading is a little bit easier, it's not as expensive, consider switching over to that 6-foot post. Now you may be asking, why is the embedment so important? The embedment actually allows a correct soil contact ratio to be achieved between the post and the guardrail. So if there's actually not enough embedment, the guardrail will not catch the vehicle and the vehicle will actually likely pass through. So now we have a situation where we have guardrail, but we're not actually shielding the object as we should be. Also, if the embedment is too much, the guardrail will actually become too stiff and will no longer act as an energy absorbing object. If for some reason the post embedment cannot be met correctly, we need to start considering a concrete barrier in the location, or you can go ahead and contact Central Office Design and we will be able to help you with some potential options. The next topic that we're going to be discussing is guardrail with curb. So this is something that is not preferred, but we understand it is completely unavoidable in certain areas, and especially our urban areas where we have some drainage considerations. To help with this, there is actually some standard crash-worthy options for cases like this located in Standard Plan 606.50. A standard rail run with curb is actually very similar to a run with no curb. There are just a couple of items that we're going to want to keep in mind when we do have curb in the vicinity of the rail. Number one, the height of the rail is actually still only 31 inches from the road surface to the top of the rail. The curb actually does not increase the height of the rail. So even though it may look like it, we're still looking at that 31 inches. It was actually not tested like that, or sorry, excuse me, it was not tested with the rail being higher than that 31 inches. So that is why it's important to make sure it's still at that 31 inches. The other thing to be mindful of is that you may want to include a pay item for backfill behind the curb because like we just discussed, the embedment still plays a very large role and is an important one. Now we actually have two standard curb designs with guardrail. The first one is actually going to be in the top right here, and that's going to be a design that includes the run of rail being flush with the curb, and this would actually be considered our main standard. Really, the main advantage here is that when a vehicle interacts or with the guardrail, it's actually going to be interacting with the curb at the same time. The second standard that we have is that the guardrail can actually be offset 6 inches from the face of the curb, which is considered our alternative standard. You'll notice that in the bottom right where we have our alternative MGS at curb. But one thing to keep in mind here is that the 6 inches is actually going to be the max distance it can be offset. Any farther actually begins to lead into some ramping scenarios. We may have a situation where the rail does not catch the vehicle as it's supposed to. So the advantage here, and the reason that this is a standard is that it's really just a good option for areas with nuisance hits, or you may have a route that has snowplows on it frequently. So this actually may protect the guardrail just a little more from having to be repaired. So kind of building on the guardrail with curb discussion, crash-worthy internals, or what we like to call CETs, will most likely be located in the area as well if you do have guardrail with curb. This is something that has been discussed frequently, and Sarah and I have been asked about this several times on guidance for this. So because of this, there is actually some new MoDOT guidance coming out related to the situation. It will be located in EPG 606.1, but it really just boils down to the drainage area, or the drainage needs in the area. The guidance is going to state that the curb should be reduced to a maximum height of 4 inches for the entire run of CET, plus an additional 30 to 50 feet upstream of it. So overall, this is actually going to result in an area of 80 to 100 feet having no curb or reduced curb. The curb height selected actually just needs to be based on the drainage, though. So the shorter that we can have that curb, keep in mind with a max of 4 inches, the better off we're going to be. Now, one thing to note that this guidance is actually not in the EPG yet, but we have submitted it. So hopefully it will be available actually in the next quarterly update. So when that is available, we will make sure that we send that out and everyone is aware. Manufacturers actually have a little bit of different guidance when it comes to using a CET with curb. If you've looked at the stop and their installation manual, which is actually one of MoDOT's 2 MASH approved Type A and terminals, they actually recommend no curb be allowed for the entire installation of it. So right there, MoDOT is actually going beyond what the manufacturer recommends. So the other MASH approved Type A and terminal is the MSKT. And they have verbally committed to a 4-inch curb height being allowed with the installation, but we have not been actually provided that in writing. If we do not get something in writing, it's important that we continue to follow the MoDOT guidance. We can't actually accept something verbally stated unless they state it verbally and provide us something in writing. Again, we understand curb is hard to avoid in situations, especially in urban areas where there's a lot of drainage, but this is why it's important that we continue to follow MoDOT guidance and why it's being developed. So some of you actually may be asking what the big deal is with a crash-worthy internal and a curb, but really just the truth of the matter is that a CET has actually never been physically crash tested with a curb. There's nothing definitive saying adverse effects will not occur. There have actually been several models that have been conducted that have shown some promising results with curves up to 4 inches, but until physically crash tested, it's just really unknown if the CET will catch the vehicle properly. Some good news actually related to this topic, though, is that this is really a topic that's discussed all the time at the pool fund meetings and really gaining some good traction. There's potential research projects that may be on the way to hopefully solve most, if not all, of our problems. This is actually just not something that's a concern in the state of Missouri. Several states have this very same concern when it comes to crash-worthy internals with curb. So continuing on, the next topic that we are going to be discussing is median pier protection. This can actually be a challenge at times, but really this is just a situation where it's really important that we're making sure that we stick to our standards or as close to our standards as we can. Our standards for median pier protection can be found in 606.51, and the 2 scenarios that are determined by the width of the median, which is actually either 60 foot or less or greater than 60 feet. One of the biggest challenges with median pier protection is that MoDOT has a lot of guard cable on major routes. So this actually may create some interference with that pier protection. These safety devices that are protecting or intended to protect 2 different obstacles. So the challenge is, how do we make sure that we're still accomplishing both? We want both of these obstacles to protect what they're intended to do. If you actually look at the picture here, this is an example of median pier protection for median is less than 60 feet, and the guard cable end anchor is actually terminated 20 feet from the Type B crash cushion. This is actually a standard design located in Standard Plan 606 or 606.41. So anytime you encounter a situation, just go ahead and make sure that we're following the standards. It's the best thing that we can do in these situations. On the other hand, though, you may actually encounter an area where median is greater than 60 feet and both median pier protection and guard cable are needed. There is actually no standard design for criteria like this, so the best information I can give you is to go ahead and contact Central Office Design and let Sarah and I help you. The design is actually going to be strictly be case by case, and it actually may even be peer to peer in the same project, but we can certainly provide you a solution that works. So an example would be that we have a 3-mile project, and there may be 2 bridge piers that we're looking at protecting in that 3-mile span. But the designs for those 2 piers may be different. Now, granted, they're most likely going to be similar, but like I said, it's still case by case where we need to make sure that we're distinguishing between the 2 piers. Now, the next topic that we are going to be discussing is bridge approach transitions, but I'm going to go ahead and hand it over to Sarah to discuss this next portion.
Thanks, Nick. The next topic is transition sections. So there are 3 different standard vertical barrier transitions, 2 for bridge ends, bridge barriers, and 1 for vertical barriers. These standard transitions are shown in Standard Plan 606-60. Next. Bridge ends often have curbs for drainage purposes. For bridges with regular curb or no curb at all, you'll want to refer to sheet number 2 of Standard Plan 606-60. In this standard, the curb will typically end before post 8 or where the transition section from thry beam to regular W beam begins. The yellow highlight indicates where a note will be added to indicate this is the first standard location for a crash-worthy end terminal. Next. This photograph is an example of a bridge end with no curb. I had a hard time finding an example photo with no curb on it. So if this guardrail were to be updated to MASH standards, you would use the top drawing of sheet 2 of Standard Plan 606-60 for the correct barrier transition. The minimum standard transition length, including the crash-worthy end terminal in this situation, is 87 feet 6 inches. Next. When the curb extends further than post number 11, an additional 12 feet 6 inches of nested MGS-W beam is required after the 6'3" transition section. Curbs can affect the deflection behavior of guardrail. So when this additional curb is at a bridge end, additional stiffness through the W beam is needed. You'll want to use the drawing on sheet number 1 of Standard Plan 606-60 when you encounter a bridge end with extended curbs. The minimum standard transition length for this scenario, including the crash-worthy end terminal, is 100 feet. Next. In this photograph is an example of a bridge end with an extended curb. Next. Vertical concrete barrier, like those used for concrete medians or for pier protection, have the same transition installation as a bridge end with regular or no curb. You'll want to use the second drawing again on sheet number 2 of Standard Plan 606-60. The yellow highlight again is where we're going to include a note to indicate this is the first standard location a crash-worthy end terminal can be installed. Again, the minimum standard transition length, including the crash-worthy end terminal, is 87 feet and 6 inches. Next. This photograph is an example of a vertical concrete barrier protecting bridge piers. Now I'll turn it back over to Nick to talk about another alternative transition design.
All right, thank you, Sarah. So just to kind of build on what Sarah had discussed a little bit, we just wanted to discuss a potential alternative design to our standard bridge approach transitions. You know, sometimes the design parameters that we have make it difficult to implement what is actually in our standard plans, and so we may need that alternative design, excuse me. An example scenario of this would actually be when a design includes a bridge transition that is located on a curb or actually has limited right-of-way. So if you actually look at this picture here, we have an example of where this bridge transition would actually not fit, but we know that protection is still needed. The solution here actually utilized a standard end anchor that is tensioned and installed per Standard Plan 606-80. I do want to iterate that this is only for a downstream roadway and cannot be implemented elsewhere. In this situation, the curb is located and protected behind the barrier, therefore it is unexposed and not a concern on the downstream end. Some things to keep in mind for this design, though, is that the guardrail needs to be far enough behind the concrete barrier to ensure adequate redirection of the vehicle. If not, it actually presents a gating scenario as the rail is not strong enough. Gating means that the guardrail will actually swing back and allow the vehicle to pass behind it instead of catching it and redirecting it. A good rule of thumb to really help prevent this is to have at least the first 3 posts protected by a margin of 25 degrees. The picture on the bottom of the screen is a really good example, and you can see that the critical impact point is at least the 3rd post. So when we are installing these in the field, that is very important that we're making sure that we're accomplishing that. Also, when we do use this alternative design, the post embedment and embankment actually must be met in this situation as well. So if for some reason you cannot meet the embedment or the embankment, this design is actually no longer an option. If you recall our earlier discussion, the correct post embedment is imperative to the success of the guardrail. The next topic we're going to discuss is, before we kind of get into our standard installation analysis and design examples, is the qualified products list and its importance. This is actually known as the QPL, but this is just a listing of products that have been reviewed and accepted for use by MoDOT on MoDOT's right-of-way. Products on this list are the only products that we can use, so do not go pull a product off of Federal Highway's website or use another state's QPL. Really, it comes down to the acceptance process varying from a federal standard to a state standard, and will also vary from state to state. So only follow MoDOT's QPL. Now, like mentioned earlier, the current direction is to use matched items. So when you are selecting the device from our QPL and a matched item is available, we are actually requiring it to be used. Now, with that being said, the matched device may not always fit the design and therefore it is not applicable, but it still needs to be considered first. In this case, or in a case that you have a matched item selected but it does not fit your design, NCHRP 350 devices may be used in its place, which is why we actually have 350 devices still on the QPL. We don't want to eliminate our options when we still need to protect something. An example of this is where we had a project that called for 6 matched crash cushions to be installed in 6 different locations, but the current approved matched crash cushion was actually not wide enough to protect the area. So this is kind of a limitation that we had discovered immediately. So in this particular case, this is a good example of why we still have these older devices still in our QPL, and we allowed 350 crash cushions to be used in its place. With matched items, there's still a limited number that's available. So these 350 crash cushions actually had several options where there were adequate widths. Now, some categories will actually not have a matched item available, even though it may be called out. The Type B crash cushion is an example of this, where our standards do call out match, but we do not have one approved. So to iterate, the importance of those 350 products again, in cases like this, we need to use the 350 device. They are still approved, they're still a standard, and they're still our best current option to use. So like I said earlier, do not go to Federal Highway's website to find a matched product just to meet your needs. We need to stick with what we have accepted because that's what our standard is. The last thing that we're going to be covering before we get into our specific design examples is the standard installation process. Anytime we go into a project, there are questions or types of questions that we should be asking because this is actually going to help us dictate the direction of the final design. The very first thing that we should always consider or ask ourselves is if a standard installation can be achieved. As I've mentioned a couple of times, we need to follow MoDOT standards, specifications, EPG policy, wherever and whenever possible. New projects should not actually have as much trouble with this, but this is actually where scoping is important to help identify the parameters needed to meet our standards. The second thing that we should always ask ourselves is that if you cannot meet the standards, the second thing that we should be asking ourselves is if you cannot meet the standard, why? Why can't you meet the standards? Understandably, the standards will just not work in scenarios or situations, and especially in retrofit scenarios. But sometimes the why can actually lead to a standard installation depending on the correction needed. Some common main obstacles that you may actually encounter that will prevent or make a standard installation more difficult will include, but it's not limited to, number one, we may have entrances or driveways that are being too close to a bridge end. You may actually have spread footings that prevent correct post embedment. So you may have an obstacle that is too close to the road, and you're trying to protect it with guardrail, and you just can't meet the post embedment. We also have a lot of old bridges, and sometimes they are just not tall enough for the new standards here at MoDOT. So a lot of times this may be effective, or you may have this situation in the rural areas. And then the last thing that you may encounter is that we have a lot of drainage installations, and sometimes this may pose immediate or future challenges depending on how they are installed. So like I said, these are just common obstacles or challenges that you may encounter, but the last step to the analysis portion is the documentation. You may have already heard me say this, but we cannot stress the importance of this enough. Any decision made on a project and the basis for that decision needs to be a part of the documentation process. Number one, this is actually our best defense when it comes to legal cases, as it provides the full thought process on the design. Number two, even in standard installations, documenting is important because it helps identify parameters for future maintenance or design projects. And then lastly, retrofit scenarios may not always be standard, but this actually lets us help our future designers know what decisions were made and why they were made. So all documenting does is lead to future success here at MoDOT. So now I'm going to move on to an example. So that will help demonstrate the standard installation analysis process. Remember, we are always looking for a standard installation. So what are some of the components of this project that will help us actually get there? Number one, the first thing that we should be always asking, I'm getting ahead of myself. To demonstrate this, we're actually going to be looking at a bridge entrance too close to an entrance too close to a bridge. Determining the example is probably helpful when explaining it, so I apologize. In this situation, like I said, remember we are wanting to look at that standard installation, so we need to identify all the components that are going to help us get there. So number one, the first thing that we should be asking in this situation is if we can actually close the entrance and ask ourselves why it's needed. Once you have those answers, it needs to be well documented and you can move on to your next question. If the entrance is needed, we need to be asking ourselves, can it be moved? If it is still needed for some sort of functionality, there actually may be an opportunity to place it in an area that it can still be used, but we can still provide a standard installation. Again, once we have this information, we're going to want to make sure that we're documenting that information or documenting that. The third thing that we need to consider is that if the entrance cannot be moved or closed, the next item that we would be asking ourselves is if we can wrap MGS guardrail around the radius. Sarah will actually discuss this further in a later slide, but some discussions need to be had for that to happen. And then again, we're going to want to document the decision. You're going to hear me say document a lot, but like I said, it's very important for the entire process. The fourth step in the scenario like this is that, if we can't wrap MGS, we need to start looking at some alternative solutions. This is when it's time to really consider the length and need, the site distance, crash history, and any other parameters to kind of make that final determination. At this point, two options really remain for us to provide some sort of treatment for those bridge ends, but we know we have to protect them. If the parameters actually warrant wrapping the guardrail, we can still use the type A rail or the old standard to wrap around the entrance, so we are still providing some level of protection. However, if you do an analysis and you decide the radius does not need to be protected based on the parameters, crash cushions are actually still an acceptable means to protecting those bridge ends. You can actually see in this picture here that crash cushions were opted for over wrapping the rail. Again, the document the decision and every basis for it. All of these questions need answered, and this is, like I said, will just only help set us up for future success. So this is a really good example of where a future designer may be looking at this and asking why crash cushions were used instead of some of these other options that we have. Now that we kind of have an example analysis under our belt, we're going to move into some more design examples. These examples are all topics that you will most likely encounter at least once because they're just more common, or there's actually some unique installation situations that may just provide some good insight. One of the most common design elements discussed is the deflection limits to an object. When an obstacle is being protected, This is something that must be considered. So kind of like what all goes in to determining that deflection limit. Well, the very first thing that we always need to determine is the object location. If you recall some of the clear zone discussion that we've had in the past, we need to look for an opportunity to move that object if we can. The second thing that we need to be identifying is the distance to the object. If you were putting in guardrail, this is actually going to help you determine the post spacing that you're going to be using, and it's also going to help you identify the length of need. So the closer that roadway is to the object, or farther away that roadway is to the object, will actually affect how much guardrail you need to protect it. The third thing that we're going to be looking at is making sure or asking ourselves that the post embedment can actually be achieved correctly. If you recall another earlier discussion, post embedment is imperative for guardrail to function correctly. So that's something that we always need to be checking and asking ourselves as well. Now, you may run into a situation where you can't reach the correct post embedment. This is kind of an area where we need to start considering long span guardrail and look for an opportunity to use that. Long span guardrail is a great option, but it does have its limitations as well. The max long span gap is actually only 25 feet, and the deflection distance needs to be 8 feet, which is much larger than any of the other deflection limits in our standards. So if these parameters cannot be met, it is no longer an option. Now, the fifth thing that would be considered in this process is that if you cannot meet the deflection limits or you cannot meet the post embedment and you have actually considered long span, your last option is just going to be a concrete barrier. However, concrete barrier can be expensive, but it only needs to protect the obstacle and the guardrail, only protect the obstacle, and then you can use guardrail to protect or finish out the remainder of the length of need. Again, we've asked ourselves a lot of questions in this little design or standard analysis. We need to document everything that went into the consideration for this decision. So now I kind of want to just move into a little scenario. If you actually look at this picture on the right, we have a sign truss that's been installed very close to the roadway and is currently protected with guardrail, but the guardrail is actually being looked at to upgrade to the MGS standards. So this is kind of where the standard installation analysis will come into play. So when looking at the scenario, the first thing, like I said, to do is identify the object and consider moving it. Being a sign truss, it's actually not one of the easiest things to move. So it just really wasn't a great option for this situation. The second parameter identified was the distance to the obstacle. When we identified that distance, it was actually only 1 foot. If you look at the standard plans, the minimum distance for a deflection limit for guardrail is actually 1 foot 6 inches. So right away, we actually knew deflection limits would not be met here. If you recall the previous slide, the deflection limit has to be met in order to use guardrail. So if we can't, that's when we need to consider these alternative options. So because of this, the concrete barrier was actually selected as the final solution. Like I said, the barrier only needs to protect the obstacle, so it may not be very long, as you can actually see from the pictures, but guardrail can then be used to finish out the length of need. One thing to notice is that the bridge approach transitions are needed on both sides if concrete barrier is selected though. So that's just something that we're going to want to make sure that we keep in mind. The barrier at least needs to be long enough that we can have the bridge approach transitions on both sides. To just build on this example a little bit, there was actually a very similar situation on a project where an object was being protected by guardrail, and again, they were looking at upgrading it. In this case, the deflection limits were actually able to be met to allow guardrail to be used. However, upon removing the older guardrail, they had actually discovered that some spread footings were preventing the correct post embedment, and that the previous contractor had actually cut the post on the original installation. This is a huge no-no, I guess, in that the post should never be cut because they are that length for a reason. This is just kind of another example where concrete barrier had to be selected because the post embedment, could not be met despite the deflection limits being acceptable. So again, there may be various things that you need to protect. Like I said, concrete barrier is always an option, but if you do have or the opportunity to use guardrail, we just need to make sure that we're kind of checking all the boxes and that it can be installed correctly. So our next design example is actually going to involve guardrail being upgraded coming off a bridge end. But as you can see from that picture, it's essentially right next to an intersection, and the bridge approach portion actually falls along the curb. So in cases like this, the very first thing that we need to consider is if MGS can even be installed. In this particular situation, the answer is actually no. What happens is that the thrive beam is actually too stiff to bend around the curve in a safe manner, so we automatically know MGS cannot be used. This already limits the number of options to be considered if we can't use MGS. We would still like to at least use a mash crash-worthy M terminal, but there's some things that we need to do and ask ourselves of, how do we get there? Well, being an older bridge, the NCHRP 350 or Old Bridge Approach standard can actually still be used from standard plan 606.22 around the curve, and then we can actually utilize a block and height transition on the tangent portion for that mash crash with the internal. The other option that we can consider is a concrete barrier extension, and then again we can use that to wrap around the curve till we get to the tangent portion. Then we can just use a standard MGS installation coming off of that. This is actually a really good option for when older bridges are too short to accommodate our MGS, like I said, which is something that we do encounter in the rural areas or just on older bridges. So always keep that kind of in your back pocket because barrier extensions are just, like I said, a good option. Keep in mind that both of these options may need a design exception, so definitely be checking the EPG for that. Or if you have any questions at all, go ahead and contact Central Office Design and we can certainly help you identify if a design exception is needed. So now I'd kind of like to move in a scenario that really highlights this discussion. If you refer to the pictures, there is actually work being completed on the perpendicular roadway to the bridge that is located at the intersection. The area is, very low speed, so the guardrail, when looking at your clear zone limits, is technically out of it. And it's actually located on a minor route. So per the EPG, it can actually be technically left in place if it is serviceable. However, just to kind of highlight what we touched on before, this becomes a situation where it may be a while before that guardrail is touched again and unless damaged. And like I said earlier, we do not want to kick the can if we are in a position that we can upgrade it now. If you look at this guardrail, it's actually very old and it is actually shorter than the minimum 27 3/4 inch height that we at least recommend for our guardrail to meet. And then, like I said, one other thing to consider in a situation like this is, we always need to be looking at driver perception. While it may not be one of the calculated design parameters that we have, we always want drivers to feel safe and confident on our roadways. So in this particular situation, where that roadway is perpendicular to the bridge, there's actually a turn lane right here on the inside. So while the turn lane is not accounted for in the clear zone, it is obviously still traversable and needs to be considered, especially when we have that blunt end exposing it. So what is the solution for this example? Well, based on the discussion that we just had, MGS cannot be used here for a couple of reasons. Number one, like I said, the bridge approach actually falls within the curve or the radius. And then number two, the bridge is actually too short for the MGS installation. So we knew that some sort of extension was going to be needed. Excuse me. Like I said, we still want to have that mash crash over the M terminal at the very least. So while we are not meeting all of our standards, we are still, meeting at least a portion of it, and that, there are options to accomplish this. As we discussed the options, which were the block and height transition or the concrete barrier extension, it was noticed that maintenance access behind the guardrail was actually going to be eliminated because of the minimum length that's required with a mash crash of the internal. So this actually kind of eliminated the mash installation option itself. However, this is actually a really great example of why we need to always consider maintenance, because they still have a job to do as well. It's not always going to work out, just kind of plain and simple, but maintenance always needs to be a part of these discussions so they are kind of aware of what's going on as well. So kind of at this point with this project, we're pretty limited on options, but we can still utilize an NCHRP 350 option, and that is actually what was selected. So this is, again, a further example of why we need 350 products on our QPL still, because really until more research or testing is conducted with products, we still just may need them on a limited basis. As always, document every aspect of the decision. So this is, like I said, a situation where Guardrail is still upgraded, but just not the MGS. And future designers may have questions of why that was accomplished. Sorry, excuse me. Got sidetracked for a second. So as I mentioned prior, if an MGS installation cannot be achieved, we still want to make sure that we have that matched pressure of the M terminal at least, or at least try to get that installed. If you're looking at the picture here, this is actually a really good example of a barrier extension. The barrier was tall enough, but it just kind of happened to fall on a curve. So the barrier was extended around the curve until we approached the tangent section where MGS could be installed. One thing that we're always going to want to keep in mind, and especially intersections as you can see here, is that we don't want to create sight distance problems at this intersection. So if that is actually occurring, you may just want to go ahead and consider the block and height transition option instead, because we don't want to block off the view for our drivers. With that, I'm going to go ahead and turn it back over to Sarah to discuss a few more design examples, and that's going to be starting with MGS and radius.
Thanks again, Nick. So the big question on everybody's mind is probably, can MGS guardrail be used in a tight radius? And the short answer is yes, it can. However, it does have some limitations. MGS is stiffer than the previously used 350 type A guardrail. And when wrapped around a radius, it is also in tension, and it also making it not only stiff, but it's slightly brittle as well. When MGS guardrail was crash tested in a radius, it tended to rupture or, let the vehicles pass through it, specifically when it was hit on a near head-on, straight-on angle. The radius of guardrail is discussed frequently and a center of attention at our pooled fund meetings. Texas Technical Institute has crash tested and successfully passed MGS on a radius. The setup of the successful test, however, required between 10 and 20 feet of embankment behind the guardrail. This is not a feasible option for many of Missouri's retrofit locations. So the design team needs to weigh the benefits versus the risk at tight radius locations. Things to consider are the crash history of the location, what is the speed limit, what is the volume of vehicles. If the benefit of installing the MGS guardrail outweighs the risk of having no guardrail, then MGS should be considered. What if MGS isn't an option though? Then there are other options, such as installing 350 type A guardrail, Nick spoke about that earlier, installing crash cushions, and installing concrete barriers. The main thing is to exhaust all standard installations and devices before moving on to non-standard installations. You can always contact Central Office Design for help in determining what your options are. Next slide. Sometimes you will run into a situation like these two drainage features shown. Drainage features should be considered when upgrading guardrail. If drainage features are not identified during the design phase of a project, they can lead to problems in the field for MoDOT inspectors and contractors, costing both time and money. In both pictures, the drainage features are located within the bridge approach transition of the new guardrail. It is important for transitions to have the proper post embedment. Do not let contractors cut the post to make it easier to install the post through those drainage features. Next. As you think of possible solutions for these two scenarios, some things to consider are, if the minimum post embedment cannot be met with the standard post, can 8-foot posts be used? The answer is no. 8-foot posts cannot be used within the standard bridge approach transition due to the increased stiffness created by the additional embedment length. A modified transition section or other solution may be needed. Can fill material be added to help meet the required post embedment? Yes, but this could potentially fill the existing drainage feature, causing it to no longer perform as intended. It could also cause material washout. It might actually be necessary to reconstruct a new drainage feature. Can 8-inch blocks be used in place of 12-inch blocks, allowing the reuse of existing post holes? Yes, if the post hole spacing meets the standard spacing for the transition. Keep in mind, 8-inch blocks are not a MoDOT standard and will need a design exception or a change order. This will also help keep the post closer to the road for embedment purposes and eliminates putting a second hole in the drainage feature. When the posts are on a slope and or in a drainage feature, there is concern that the aggregate around the post will wash out. In this instance, a thin layer of asphalt, 2 inches or less, can be placed over the aggregate in the post hole. Care needs to be taken not to go over 2 inches of asphalt or pile up around the post. This will affect the lateral movement of the post. Please refer to standard 60650, sheet number 5, shown, for the post hole installations. Decisions on how drainage features are addressed need to be included in the project files in eProjects. Now back to Nick.
All right, thank you, Sarah. So the next design example that we're going to be discussing a little bit is just the post embedment, but we're going to be looking at it on a little bit of a different capacity because this actually relates to maintaining the post embedment. As I mentioned early on, post embedment is imperative to a correct guardrail installation, and that includes maintaining it. When it comes to incorrect post embedment, rock washout is one of the most common causes of this. The installation can be done correctly, but it actually might often go unchecked just because it's brand new. So we assume the installation is still correct, but that's actually just not always the case. If you are experiencing some rock washout, you might want to consider some of these items. Sometimes the slopes are steeper behind the guardrail, so you might want to consider a larger 4-inch rock. This is actually going to replace the specified materials located in EPG 215, but it actually does provide more stability than the base rock. So you may not experience as much washout if you do use a larger rock. Keep in mind, though, that when we do have these steeper slopes, you still want to make sure that the top portion of that slope is flat or flatter, so that way we can still install our crash over the end terminal correctly. The second thing that you might want to consider is providing a heavy tack coat on the base rock. If you actually are looking at the picture right here, this is actually a great option to prevent any washout from occurring, and really it acts as a vegetation control, so we have a kind of a twofold benefit there. Because of options like this that I have just discussed becoming more popular, there's actually a non-standard JSP that was created, and that is NJSP 20-03. So if you have any questions regarding it, don't hesitate to reach out again to Central Office Design, or you can reach out to Central Office Construction Materials because that JSP was created in collaboration with them. The last thing that you might want to consider is to always just put the post in asphalt. You may find it is actually not much more of an additional cost when you are doing an overlay, but this will actually allow for proper embedment without erosion for a longer lasting installation. If you do this option, just make sure to follow the standard plans that Sarah had mentioned because we do have details for post and asphalt. So the last design example that I will be discussing is what we call our buried in backslope, or what we also call a bib. You may have heard it referred to as an embedded end terminal as well, but all three are actually referencing the same design. So this is something that isn't used as much compared to our MASH Type A end terminals, but this is just something that we highly encourage. Both have their advantages, but we just wanted to highlight some aspects of using a bib that you may have not considered for your design, really just why it's still a good option. So the very first thing that a bib allows us to do is that it actually reduces the opportunity or risk of hitting an object within the clear zone. If you recall our earlier discussion, even though guardrail is crash-worthy, it is still an object to hit. And anytime that we can just reduce the amount of objects that we have in the clear zone is just a very clear advantage that we just need to look at taking advantage of. The second thing is that it actually still provides an acceptable and often shorter length of need than a standard tangent run. This is due to the guardrail flaring, so it is still able to adequately protect the object just on a much shorter distance. And then lastly, one unique advantage about a bib is that it actually doesn't have to be physically buried in a backslope. Our standards have a detail that allows the bib to be bolted to a rock face. So just because there is a rock shelf doesn't eliminate the opportunity to use it. So just kind of keep that in mind. One thing to look out for, though, with using a bib, especially during the installation in the field, is the rail may actually kink. Anytime we actually flare guardrail, it does present that opportunity, but bibs has several flare rates sections along it, so it just may be more prevalent, or the opportunity is just greater. So kinking of the guardrail does not actually promote a smooth transition and can be hazardous when hit. So that's just another thing to keep in mind when you're using bibs. Now, when you do install a bib, sometimes rub rail may be needed depending on the area or the terrain that is being placed. The reason rub rail is important is because it actually prevents smaller cars from going under the guardrail. So while it may be stiffer, we are still catching the vehicles as intended. The rub rail condition is based on the depth difference from the bottom of the V-ditch to the bottom of the rail. So if it is 18 inches or more, we must include rub rail in the design. If you look at the picture on the slide, this is actually just a really good example of when rub rail is needed, and it is actually installed on a rock face as well. So both can be done or accomplished at the same time. So like I said, just because there is a rock face, that actually does not mean we should shy away from using it. There is one misconception that I would like to share, and this actually may help with the kinking, is that this actually may help with the kinking, but all of the flare rates, or most of the flare rates on a bib are pretty flexible. So if you look at the standard plan here, these flare rates are actually considered a max. So if you are experiencing kinking, these can actually be reduced or relaxed a little bit to help provide that uniform transition that we're looking for on guardrail. So just always keep that in mind, that these are flexible. So depending on where you're installing it, you may be able to lax those a little bit, and then we'll be able to provide that standard guardrail design. Now, one last thing to note again when using bibs is that sometimes it actually may cut off maintenance access. So again, we're always going to want to include maintenance on these discussions as well. We just want to always make sure that we're communicating with all parties that will be included. And so this just allows them to be aware of the situation, and it maybe allows them to even plan for how they're going to maintain that area as well. So with that, I'm going to go ahead and hand it back over to Sarah to discuss one last design example before we kind of wrap up and answer some questions.
All right. Standard Plan 60650, sheet number 7, shows details for a long span MGS guardrail. This works great at box culvert locations or when there is plenty of deflection room. But what do you do when you encounter a utility or an obstacle at a bridge end, like shown in the picture? Is it okay to skip a post at this location? It depends. If relocating the utility or obstacle is out of the question, skipping a post might be an option. Typically, the bridge transition is stiff to prevent the vehicles from impacting the blunt end of the concrete bridge barrier and/or helps deflect vehicles away from the concrete barrier. We typically do not recommend skipping the first post after the concrete bridge barrier. When the first post is skipped, it has the potential to create a pocketing impact rather than a deflecting impact. When a vehicle hits that pocket, the vehicle could impact the concrete bridge barrier. However, this is again a situation where the benefits versus the risk need to be weighed and considered. Is there a crash history at this location? What's the speed limit? What is the volume of vehicles? Is this on the downstream end? Or is it likely that it could be hit by opposing traffic? If this is a low risk location, then skipping that first post is an option. The decision to skip the first post needs to be documented with a design exception or a change order and then filed in e-projects. What if the post you want to skip is the second or the third post in the bridge transition? The further the skipped post is away from the concrete barrier, the better chance the guardrail will perform as intended and not pocket upon impact. Again, the decision to skip a post, any post, needs to be documented. Another solution in a situation like this is to use double blocks. Double blocking up to 24-inch max helps move the post back an additional 12 inches to where it might miss the utility or the obstacle. This option keeps the stiffness and integrity of the guardrail and is less likely to create a pocket. We typically recommend only one post in the bridge transition be blocked or double blocked. Vehicle tires can snag on the guardrail post if too many posts are double blocked or set back from the rail itself. This is also a non-standard installation requiring documentation. Now back to Nick for final wrap-up.
Thank you, Sarah. Sorry, I apologize. I forgot to unmute there. So I know that we've actually talked about a lot today, and I hope, that whether, this information is new to you or your experience, that you are still able to take away a few items that will help you, with the designs or in the field. The final items that Sarah and I would really just like for you to take away at a minimum, and that these are just things that we cannot stress enough, are number one, we always want to stick with the standards as much as possible. Those are our standards for a reason, and it is important that we're consistent across the state. We understand that it's not always possible, and especially in retrofit scenarios, but we still at least need to try. And those are the first, things that we always need to look at and consider. The second thing is that, if standards can't be followed, do not ever hesitate to reach out to Central Office Design for some potential options. Sarah and I are actually aware of some crash-worthy options that are not standard, so we may be able to provide a crash-worthy solution, but these are just strictly case by case and actually may not fit all areas, which is largely why they are not a standard. We're always happy to help though, so if you have any questions at all, just like I said, don't hesitate to reach out to us. And then the last item, which is, like I said, something you've probably heard me say a bunch today, and same with Sarah, is documentation. Documenting the scenario and the installation is the most important step. This helps defend MoDOT now and in the future. It also helps understand future designers understand why decisions were made and what those decisions were. So, like I said, even in standard installations, it is always important to document the decisions and why. Things change. It could be 5 or 10 years before that project is looked at again, or maybe have some additional work, but sometimes things just change. So with that, this does conclude our guardrail training. So Sarah and I will be more than happy to answer any questions. I do want to point out our content information though. So if you do not have a question now and have one later, like I said, feel free to reach out to us and we can help you. Just with that, I hope you enjoy the training and you're able to take some things away. And just thanks for being a part of it. Like I said, we appreciate it.
Okay, so we will start with our question and answer session. Thank you to our presenters today. A lot of information we tried to squeeze in there for you. We'll start with some questions that have been sent in through our question and answer box first, and then we'll open the floor to those verbal questions. So like I mentioned at the beginning of the webinar, there's an option there for you to raise your hand in the WebEx tools. So you can click on that button and then we will unmute you and state your name and then ask you to ask your question. We have received a lot of questions today, and that's really great, and we appreciate receiving all of them. We will hopefully get through all your questions. If we don't, we will personally follow up with you after the webinar and talk through your question with you, and hopefully we'll have an answer. Kind of like Nick and Sarah said, there's a lot of different scenarios, so everyone is different, and while they get a lot of those every day, sometimes it never fails. There's one we haven't had before, and we may just have to research it a little bit, or there's sometimes we have to just say, I don't know. But Nick and Sarah, like they said too, are always here to help you work through those scenarios, so never hesitate to reach out to them. We're all learning about this and everything's always changing. So we'll get started then on the questions. We have a couple that are related to design and some that are construction. So we'll try to start with some of those design questions first. So a question was asked, Nick and Sarah, regarding the CETs with 4-inch or less curb, would that require a design exception to document the design decision?
So right now we don't have anything in the EPG. So a design exception never hurts. It's really just another form of documentation, and we should consider that design exception when we are doing it. Now, as we move forward with guidance or new standards become available, it may not be a design exception. But like I said, we're just not to a point right now where we have enough MoDOT guidance official, in the EPG or standard plans or whatnot. That it shouldn't be a design exception. If I miss anything, Sarah, like I said, feel free to jump in.
Okay. Our next question is, if you have guard cable on one side of a pier, do you need guardrail protection on that same side?
So, yes, largely just because, like I said, they're still intended to protect two different things. And I know sometimes that can seem, redundant. But if you look at it from a cost side, sometimes just running that guardrail or guard cable, excuse me, all the way along that shoulder is cheaper than ending it and starting it. So if you have and I should probably clarify this, but really this is only an option where you have enough medium width as well. Because, like I said, guard cable does have a tendency to deflect 8 to 12 feet. But yes, you should always be looking at the pier protection side along with the guard cable. It's not going to be one or the other. And so, like I said, if you have some questions about some specific designs, maybe we like I said we can always help you. But like I said, it can be done and it has been done.
Okay, our next question. Can existing guardrail be used in place if the curb below it is higher than the standard height and the guardrail is at or above 31 inches in height?
Yes, I may lean on Sarah for this. Just, I'm assuming the curb height is above the standard for a particular reason. So that kind of goes into that documentation process of, why is that curb the height it is? Ideally, we probably should look at, reducing it, but I can't answer that without knowing why that curb is that height in the particular first place. So they're just, like I said, there may be some information out there, additional information of why that the curb height was selected and the guardrail was placed at the height behind it that it is.
I think in that situation, we definitely want to keep our guardrail height at the 31 inches. But in those situations, it's always best to document that, yes, we're aware that, the guardrail is high at this location, the curb is high at this location, and document it somewhere within the project files so that going forward, we know the whys behind it. So, but in those specific, case by case scenarios, it might be good to just give us a call and we can, figure out a solution together. Good question.
Okay, our next question. Is wrapping guardrail around a radius discouraged on major highways?
So I'm going to look back at that slide that Sarah had discussed, and really it just comes down to that risk versus benefit. You need to be looking at all the parameters that go into that, because sometimes there may be a crash history there at that particular radius, and we're going to want to make sure that we protect it. So whether it's NGS or 350 rail, we still need something there. Now, like I said, not having objects within the clear zone is always the ideal scenario. So if you, for some reason, have radius or guardrail wrapped around the radius, and you're doing a crash history, maybe there hasn't been a crash in 20 years there. We don't know, and that's a scenario where maybe we can bet or be more laxed on that curve because the benefit without having it is greater. Hopefully I answered that question. So if, like I said, if I didn't, feel free to go ahead and provide another question, I guess.
Okay, we have another design related question. If we are connecting new MGS, just scroll down on me.
Oh, sorry.
If we are connecting new MGS guardrail to an existing city guardrail system that we do not own, is there a safe length that should be extended into the city system that would protect our liability against connection to a system that is not MGS compliant?
You know, as far as extending into the city system, that might just be a situation where you work out a deal to where maybe you update the entire run of Guardrail. So you may have an opportunity to go ahead and do that. And they just may be able to either pay or maintain for that section on theirs. But we do have a block and height transition in our standard plan. So if they are at of height of 27 3/4 inches, you can use that block and height transition starting at where their guardrail ends to transition to MGS. So there's not technically, I mean, it really just depends, I guess, if that's the best answer. But those are some options that you would consider. But I would maybe stress just talking to the city and, maybe working out an agreement with them where we can actually just go ahead and upgrade that entire run.
Okay, one question back to the 4-inch curb, and then we'll cover those construction questions. So the question is there a standard for this 4-inch or less curb, or will this require a special design, retrofit, cut down, or new installation, or both?
So it's kind of a mixture, but that is a good question. So this is kind of where the scoping is going to be very important, especially with these crash-worthy internals. But if you have an existing curb, what we're going to want to do is just have to cut down on that or saw cut it. But if you're doing a new design and you know that you need a drainage area, that needs to be pointed out in the standard, or not the standard plans, but the project plans, that this curb here is actually going to be shorter. So it's kind of a situation where you might encounter both, but there's really not going to be a true standard that I think that we will use, unless Sarah may be able to provide a little more information if we do need a standard. But no, that's just going to be where the scoping is going to be important, and comparing that with our EPG guidance.
There won't be like a standard plan for it, but there is going to be updated EPG guidance for it. And of course, then, if the condition can't be met, then it's always important to, like I said, document it with the project files, either through like a design exception, or Brian, in your case, when you're out in the field already, with a change order.
I do want to point out that this guidance is probably going to be evolving within the next 5 years again, just because, like I said, it is really just a very popular topic with the pooled funds. So right now we're just doing the best we can, but we're hopeful that we'll have something definitive here soon, and that will solve all of our problems, hopefully.
Okay, a construction-related question. It says, maybe not a question, but a comment, but I know we've been asked this before. Could we find a way to identify when an 8-foot post is used, as this would help when writing up work orders for repairs and replacement?
So I can take this question. We've had conversations with our industry partners for guardrail posts, and they were at one time looking at placing a stamp on the guardrail post indicating the length of it. I don't know where we are on that, but it's something that I can certainly reach out to those industry partners. Another thing, kind of a telltale sign is, looking at the embankment. If we are encountering a steep slope, 2-to-1, type, it's probably a good assumption that we're going to go back with 8-foot posts. Even if there are 6-foot posts installed there, we want to make sure that we stick to our standards as close as possible. So like I say, looking at the terrain, we should be able to tell, the length of post that we need. But a good thing too is, like Nick mentioned earlier, just because you're using 8-foot posts in one steep location doesn't mean the entire run of guardrail needs to be 8 foot. So something else to keep in mind. So hopefully that answered the question.
Okay, another construction. How do you show in design that a specific width device, parentheses, type C/D, to protect the object? Contractors will build the lowest cost device, which may not be the device of correct width.
I'll take this one too.
Okay.
I think I'll have to go back and double check. I think in the EPG, we provide guidance that, indicates we should be showing the size of type C and type D crash cushions, either on like the plan sheets or within the quantity sheets. If that guidance isn't in the EPG, we'll go back and include something to help that, it'll make it easier for our contractors as well. So I'll take a look at that and see if we can't improve that guidance.
Okay, another one. When guardrail posts cannot be driven and must be drilled due to surface or subsurface material, is this shown in the design so the bidder can determine the cost of the installation? This would be beneficial in remove/replace scenarios that then end up with drilling that wasn't anticipated.
So that's kind of a challenge because sometimes you may not know that you have to drill until you start working. Like I said, I'm gonna reference that example where where the contractor cut the post, but we didn't know that until we kind of got in there. So really, it's probably just going to come down to the scoping. I know if you do know, we just need to make that note in the standard plans, or not standard plans, but the project plans, and that way whoever's bidding it does know. But just it's going to be difficult to make that determination depending on what can be drilled through or not until you kind of get out there in the field.
And this is a comment that said, thanks, Sarah. Drainage features are one of the most common things missed into the design, and appreciate you going into detail how to address these. And let's see what else we got. So here's another question. The example where barrier wall has to be placed in front of a footing, an asphalt shoulder would need to be replaced with concrete in order to dowel the barrier. Is doweling sufficient, or does that have to be a moment slab?
Sarah, I am actually going to refer to you on that one if you don't mind.
That's
And I
fine.
believe-
Go ahead, Jill.
I think Darren's also present if he needs to help with that one.
Yeah, I might tap Darren for that as well. It's my understanding that you can use dowels in a retrofit type situation, but we want to make sure that we're still getting enough dowels in there, and that we're using an epoxy adhesive in there to also help with that for those shear moments. So, Darren, I don't know if you can.
Jessica?
I can say, can you unmute Darren?
Darren, yeah.
Yes, I can unmute him. Is it Darren Kimna?
Yes.
Okay, Darren, you should be unmuted now. Go ahead and speak, please.
Please. Oh, he doesn't have a microphone. I forgot about that. So,
He's not, okay.
yeah, Neil, on that, like I said, I believe that, we can use the dowels and that's sufficient, but we will follow up on that with you.
Okay, we had another one come in. I just gotta scroll back down to it. Sometimes. Oh, somebody mentioned that spec book 606.50.4 covers incidental costs like drilling into rock.
Thanks, Chris, for sharing that and pointing that out. That helps a lot too. Appreciate it.
Okay, does anybody see any questions I've missed from the panelists that's helping me out? I think we've answered them all.
I do have one question that was sent to, I think it may have only been sent to me in the Q&A, but it says, does it matter which type of crash with the internal is used in the design? If the contractor uses another type of crash with the internal, the length of need will change, requiring a design or redesign or change order. Both of our type A MASH terminals should be very, very similar in length of need, maybe only by a couple feet. I can't remember the difference between the MSKT and the soft stop, but it doesn't matter what type of CET that you're selecting. The length of need should be roughly very, very much the same.
If you use the length of need calculator that's out on the EPG, it has the length of the crashworthy end terminal that counts towards that length of need. So we've kind of taken that into account, and since both are very similar, you can use that length of need calculator out there, and it will also, like say, include that the length of either the soft stop or the MSKT into that. So something to check out as well.
Good point, Sarah. Thank you.
Another just comment we received. I believe that the gutter line for the type A curb that is integral with the bridge approach slab is set to line up with the back face of the thry beam. This is a bit different than the NGS standard.
And Darren's correct on that. Because of how the bridges are set up and that thry beam is used on bridge as bridge rail, it is set back a little bit different. But that's more of a bridge plan versus a roadway plan. But you can see that on the standard plans, the bridge standard plans. And we'll also follow up on that as well. Thanks, Darren.
Okay, I think that's all the questions that have come in through the question and answer box. Has anybody raised their hand or want to raise their hand, and we'll unmute you? I was trying to look, Jessica. Do you see anybody with their hand raised?
I'm looking right now. I do not see any hands raised.
Okay. Last couple. Okay. Oh, go ahead, Nick.
I was going to say, like I said, I know, like I said, I can't iterate it enough that if you do have a question later, just like I said, please contact Sarah and I. We're always available. Like I said, we enjoy, Guardrail is kind of like a puzzle sometimes, and it's an enjoyable challenge to make it work. But it does have its challenges just in general. And those are things that we're here to help you with. So like I said, if you ever have any questions, never hesitate to reach out. And like I said, we'll do our best to make sure that we get you an answer in a timely manner.
Absolutely. And we just tried to start with the basics today. If you would like to see a more in-depth even conversation, we never shy away from those challenges as well. So certainly let us know if there's more information about Guardrail you'd like to know about. We can perhaps, have a Guardrail number 2 for you. So, well then, since no other questions have come in, we want to thank you for participating in our webinar today. We appreciate any feedback on how we can improve this format or content, like I mentioned, for future webinars. We're gaining a lot of popularity with these, and as evident by our attendance we had today, we appreciate everybody's time in attending. Makes it worth our efforts when everybody's engaged and asks those questions. As we wrap up the webinar, just to let you know, we will be registering your participation today in our webinar in Mo.U on your transcript. We are able to track your attendance through WebEx. But if you attended by phone, we just often see that phone number. So be sure that you let Jessica know if you are one of those call-in numbers, or if you have a group that is attending with you today, that you get those names of all those that attended as a group with you to Jessica as well, so that we can give everyone credit for attending today's training. Look again for our next webinar opportunity. They have been renamed a little bit. I forgot, Jessica, what's the new name?
The new name is going to be Program Delivery Webinar, and then it'll be with a dash followed by whichever topic they're going over that day. So when you go to mo.u, just search for Program Delivery Webinar, and you should find all the list of the classes that have previously been done. They were out there, and then future webinars to come.
Thank you. And our next webinar is scheduled in April, and it is our engineering policy group. We'll be going through the EPG and all things about EPG. Sarah, what is our date on that one?
I think it's April 26th. I think.
So we look forward to everyone's participation in that webinar as well. So this concludes the webinar for today. Unless you have any last minute questions, you can stay on and ask Nick and Sarah as well. And we thank you for your participation. Everybody have a great one and stay safe.